So this is a Korean shower regulator on vessels. Let's go in a little bit more detail on this interesting thing. Showers. Contrary to popular belief, we seafarers do shower on board. We use distilled water produced in our freshwater generators, and then later potabilized using a mineralizer and sterilizer. And on cruise ships, we have hundreds of tons of storage for this water because each day we're using thousands of gallons. So today, let's join the shrimp of the engine room as he fixes a shower regulator, which is only giving hot water. First, let's go to our bathroom. Here we can see our hot and cold water connections. However, before removing anything, let's first isolate the shower by closing the water supply valves. Here we have both the hot and cold water supply valve. After verifying no flow, we can remove the regulator from its connections. So just in case, make sure you don't lose the gaskets that seal the hot and cold water connection. And at the workshop, as with any equipment, make sure that before you disassemble, you understand the theory of its internal components. However, unfortunately, this one is in Korean, so let's just do our best. Alright, let's review our full assembly. We have two knobs. One is a temperature regulator, and the other is the flow regulating valve. Our main problem is the temperature regulator, which is stuck on hot, which makes it dangerous for showering. Therefore, let's disassemble and see what's inside. First, we remove the knob lid, and after, with a screwdriver, we remove the screw holding the cover and lock. The assembly is held in place with an Allen lock screw, so we'll have to take that out. With the screw out, let's put some brass covers on the vice grip to not damage the knob. And with a strong pull, the temperature regulator slides out with some water. Here is the temperature regulator assembly. We can see the following things at first glance. 3 O-rings, 2 screen filters, and a push knob. So judging from its position inside the shell, the screen filters are for both the inlet of the cold water and hot water. And the O-rings you see seal each chamber so that all the mixing occurs within the regulator. Now, let's open the regulator to understand more. Using a spanner, we can remove the assembly from the knob side, like this. Let's see what's inside. With the regulator open, we can understand more of what's happening inside. First, let's look at the knob. We can see that turning has no effect on it, and the push bolt looks like it's stuck. And here we have the mixing flow blocker with a push pin. From what we can see, the push bolt pushes against this pin to move the flow blocker within the mixing chamber. And to keep the flow blocker in a fixed position, we have a spring pushing against it. Together, let's review how they all work. So, for this mixing valve to adjust the output flow temperature, here we can review all the elements. Here we have the hot water inlet, the cold water inlet, the outlet to the shower head, a spring with the flow blocker, and the flow blocker is within the mixing chamber. This flow blocker has both a push pin and a thermal dilatation element. Remember, the knob is located here with the push bolt. The mixing chamber, therefore, is situated around here, with the cold water supply going to the cold water inlet, and due to the O-ring, it will go only inside the chamber and not directly to the shower outlet. The hot water will flow from the left to the hot water inlet, and due to the O-ring, it will only enter the mixing chamber if it is not sealed by the flow blocker. And finally, we have the flow blocker, which is inside the mixing chamber. If it is fully pushed by the push bolt, that is, the temper regulator knob is fully in cold position, then the flow blocker is pressed and fully sealing the hot water side. As you move the temperature regulator knob to the hot water side, the push bolt goes in and allows the hot water to come inside due to the spring pushing the flow blocker out as much as the bolt will allow. So, the more freedom the spring has to push the blocker to the cold water side, the hotter the shower outlet water will become. And finally, the thermal dilatation element is so when there are small shifts of temperatures in the water, this element will expand or contract slightly to maintain the stable temperature. This is because it's connected to the push rod, and it will slightly move the flow blocker, keeping the temperature stable. Pretty cool, right? But if the push bolt is stuck in place, then we won't be able to push the rod to seal the hot water, therefore continuously having very hot showers. So, let's have a look at what's inside and how we can fix it. Here we'll put some WD-40 to remove any soil and loosen up the moving parts. After letting it settle for a bit, we try moving the knob slowly to free up the push bolt. If the deposits are really stubborn, we can blow some compressed air inside and slowly loosen it right out. Awesome. So now that the push bolt is free, the root problem is fixed. But now let's try to assemble everything correctly. First, the spring and the flow blocker. After, we align the push pin with the bolt. However, the problem is we don't know exactly where to put the bolt for assembly. You see, if you install it with the knob fully loose, that is, the push bolt fully inside, then the hot water will be fully open, and you might not be able to regulate the colder temperatures correctly. So first, let's have the bolt a little bit pushed at first, and then we will tighten the mixing chamber with the knob, and then a slight tight with the spanner. Afterwards, we'll align the mixing assembly with the Allen lock screw hole using a rubber mallet. We don't want to damage the brass. After we lock the assembly in place with the set screw, we can finally get started with the temperature adjustment. So a method I use for testing before putting the temperature indicator ring is to first make sure that the shower outlet valve is open. Afterwards, I blow on the supply inlets for both hot water and cold water. You see, when we turn the knob, and therefore the push bolt, we can seal one of the two supplies. So depending on the supply that we seal with the flow blocker, you can blow, and if no air is coming from the shower outlet, it's because it is fully blocked. Therefore, the other side should be fully free. Here, have a listen. There you could hear that the cold water was fully free and the hot water was sealed. What I like to do is keep it at a point where both hot and cold water are moderately free, and take this as my middle point. Then I can put the temperature indicator ring and lock it. We'll put it in the middle and then screw it all in place. And with this, we finished with the assembly. Just like before, we'll install it and enjoy a nice, warm shower.
Finally, once again, thank you for joining me in my quest for knowledge and skills. And I hope to see you next time. Success and nothing else, seafarer.